And starting January 1st in 2027, new regulatory requirements for combustible dust risks and hazards are going to go in effect. And one of the key impacts is to industries that many have not maybe considered the risk in past about dust and now will be required to build a combustible dust program. So this is the first webinar in a three-part series to help you prepare for these regulatory changes. Today's webinar focuses on the fundamentals, helping you better identify and understand the risk related to combustible dust in your workplace and ultimately understand how these changes will affect you. Our presenter today is the Manufacturing Safety Alliance's own occupational hygienist, Martin Sheridan. And so welcome, Martin.
Thanks, Wayne, for the introduction. Can you hear me?
Yes, all good.
Great. Hello, everyone. As Wayne mentioned, I'm one of the occupational hygienists here. My name is Martin Sheridan, and I'm here to talk to you today on the first steps when it comes to combustible dust and provide information about the incoming changes. So I'm just going to share my screen. One moment. Okay. Should second here. There we go. Okay. So in this webinar, what we're going to cover on what combustible dust is, kind of demystify it a bit. We're going to talk about dust fires, flash fires, and explosions, how they can occur. We'll touch on where dust typically comes from and where it builds up in facilities, the common places. And then we'll provide you with 4 key questions that'll help you determine foreseeable risk. We'll also discuss what regulators are expecting at this point and what they're not expecting at this stage. So again, the regulations have not come out. They'll come out January 1st. We just want to prepare for them. So at the end of this webinar, you'll be able to walk away with some clarity about what foreseeable risk is, and then you'll have some confidence in your first steps. So what this session is and what it isn't, again, it's about awareness. It's about first steps. We're not going to dive deep into a sampling discussion or talk about engineering controls. This is the first of 3 webinars, so that'll come later. This one is just really the first steps, awareness, and what do we need to think of before these regulations come in. So our goal is to help you answer, am I on the risk side of the line, and what do I do first? So as Wayne mentioned, in January 2027, the new combustible dust requirements take effect, and the shift is focusing to foreseeable risk. And we'll talk about what that means in a couple slides here. And it applies to more industries than just wood manufacturing. Typically, when combustible dust is raised, or the topic is raised, everyone thinks immediately wood mills or wood processing. But combustible dust can be found in food processing, grain processing facilities, facilities that manufacture and deal with metals, sugar, and a lot of other industries that can create or handle dust. So what's changing? So WorkSafe BC is introducing changes to Part 6 of the regulations. So there'll be new sections of Part 6, and they will apply to combustible dust requirements. As mentioned, January 2027 is the date, so keep that in mind. And the sections in Part 6 create specific and enforceable employer obligations. And it applies to any workplace where combustible dust poses a reasonably foreseeable risk. So your first obligation as an employer is to determine whether the regulation applies to your facility or not. So who this affects, as mentioned, it's not just limited to the wood processing and grain handling. WorkSafe BC has already put out some information about their indicators, their screening indicators that they will be using, their officers will be using when they're in the field. The 6 are listed here. So if any of these, if there's a yes answer, then the facility is likely subject to the combustible dust regulations. So if you have piping or ducting that conveys materials, so it could be pneumatic conveying with air, moving materials about the facility, or even a dust collector or bag houses if you have those at your facility. If you have a size reduction process, so something that takes a coarse powder and pulverizes it or grinds it and produces a finer powder, or it could be chipping, for example. If there are ignition sources that are in close proximity to dust, if the facility has bulk storage bins or silos or intermediate bulk containers, or if there's fugitive dust visible on elevated surfaces. So these are the criteria that the officers will be using, part of the criteria they'll be using as they visit facilities in the field. So why is this important? Why is combustible dust important? Well, what's at stake can be quite serious. So the reality when it comes to combustible dust is these incidents are among the most catastrophic of workplace events. So they might not happen often, but when they do, they're absolutely devastating to the facility and the community, the surrounding community. So when it comes to combustible dust, we think about dust layer fires. So that's just the dust that's sitting on a surface catching fire. Flash fires, also known as deflagration. So when we have the dust becomes airborne somehow, and we'll talk about how that can happen later on. And then it hits an ignition source, the cloud, the dust cloud, and then it turns into a flash fire. And then full structural explosions. So if that deflagration is contained and builds up enough pressure, it can turn into an explosion where the structure of the building or some kind of container that's housing the dust can explode. All of these are possible when it comes to combustible dust. And something else we want to keep in mind when it comes to combustible dust are the secondary explosions. So here's two pictures of some combustible dust incidents. The first one, Lakeland Mills in 2012, was a wood mill that exploded. And then within a couple months, there was also another wood mill in BC that in the same year that had a similar outcome when it came to combustible dust. And then Imperial Sugar is another well-known one. And these incidents included secondary explosions. So there might be an explosion or some kind of shock to the building somewhere in the facility, some kind of vibration, and that dislodges dust from settled surfaces, elevated surfaces. And then as that dust starts to rain down, or that dust cloud, when that hits an ignition source, it can trigger an explosion. So the initial event that caused the dust to become dislodged might be minor, but it's enough to send a acoustic shock wave in the facility, dislodge some more dust, and then you have this chain reaction of explosions through the facility. And that's what happened at Lakeland Mills. You can see the devastation from the photo there. So the reality is Works APC, starting 2027, will be conducting inspections to ensure this doesn't happen in the future. So the good news is what we're looking for at this stage, or what the officers are looking for at this stage, is progress, not perfection. So they're not looking for a completed program by tomorrow. They just want to see reasonable progress towards that aim. So the first compliance obligation is an assessment and not implementation. So many facilities will find that once they do this assessment, that the risk is actually manageable with a structured approach. In most cases, increasing housekeeping frequency and having a structured housekeeping program is enough to keep combustible dust within check, within the below the threshold where it becomes a danger. And then it's only when you can't operate under that threshold and housekeeping is not enough, when you're operating above that threshold, that's when you need to consider controls. And a combustible dust assessment can help figure that out. And there is an exemption path. So the exemption path is real. If you have no reasonably foreseeable risk, then you may be exempt. So it's in your best interest to figure that out. And we'll talk about how we do that in a couple of slides. So step by step is what Works APC is looking for at this stage. So first step is, do these regulations apply, and is there a foreseeable risk or not? So what is combustible dust? If you look it up online, you might get some kind of definition like this: a dust that is ignitable or deflagrable. That doesn't really tell us much in a practical sense at a facility. So a more practical definition would be a fine particulate material that can ignite or burn rapidly under the right conditions. It has three practical properties. So it can be generated by your process, or it can escape the process. So there's process dust. It might be an ingredient or something that goes into the process of whatever you're making, or dust that escapes, and that's known as fugitive dust. It can accumulate on surfaces or inside equipment, and it can ignite when the conditions are right. When it comes to combustible dust, the particle size matters. So the finer the dust, the greater the surface area on that dust particle, and the faster and more intense the burn is. So particle size is a determining factor when we're assessing combustible dust. And a general rule of thumb is if the bulk material burns, like the parent material that dust comes off of, if it can burn, then the dust will combust. So some common sources of combustible dust in industry. So when we look at bakeries, the food industry, we can think of flour, starches, sugar, grain, spices, flavorings, whey powder. All those can be considered combustible. And similar in the dairy or beverage industry, cocoa powder, whey, stabilizers, flavoring, even plastics or resins. So if the facility makes their own containers or bottles, there could be plastic dust that's generated, grain that can go into some, let's say like oat milk, for example. They can all be present at a dairy or beverage facility. Fabrication and assembly, so wood, metals, plastics, asphaltic dust, cellulose, synthetic fibers, powder coat, these all could be combustible dust. In the textile industry, you can have fibers, there's all different types there, dye powders. In the nutraceutical, you could have enzymes, proteins, metals, sugars, acids, minerals, amino acids. And then in recycling and processing, there can be plastics, metals, rubbers, fibers, wood, grain, or food waste. So you can see it's quite a large list here. And essentially, if it's not stone or rock or silica, then it could most likely be a combustible dust. And some overlooked examples. So for example, coffee roasting and grinding, there could be combustible fine organic dust from that process. The cannabis industry, so cannabis drying or processing, the plant particulate is combustible. And newer technologies with 3D printing. So if you're using metal powder like titanium or aluminum, those are reactive in and of themselves. So these are some overlooked examples of combustible dust. So really what we want to do is reframe the question from, am I in a recognized industry? And move the question to, do I generate fine particulate from a combustible material? That's really what we should be asking. So as mentioned before, there's two main categories of combustible dust. We have process dust, so dust that can go into what we're making or part of the manufacturing process. And that typically is held within equipment and it's enclosed in most cases. And then we have fugitive dust. So dust that is not intended to escape, but it does. It escapes through nooks and crannies and crevices or some kind of process. And there's a bit of a difference between these two. So processed dust, depending on what's being manufactured, can have its own moisture content and its own particle size. But when we talk about dust that escapes the process, it typically is finer in quality. So the fine dust is what escapes and floats throughout the facility and settles on elevated surfaces. And that dust can sit there for quite some time. And so it can dry out. And so its moisture content can be different from the processed dust. So the fugitive dust can be drier and finer compared to processed dust. So really when we're doing an assessment of combustible dust, we don't want to just focus on the inputs or what's going into the process. We want to also be mindful of the fugitive dust, because the fugitive dust is what settles on elevated surfaces and can cause problems when there's a shock to the building. So where do we see combustible dust in facilities? So we typically see combustible dust on elevated surfaces, such as rafters, structural steel, top of equipment, above suspended ceilings. That's something that's often overlooked. Inside equipment, so not just the fine dust, but also the inside equipment, it can settle conveyors, hoppers, bucket elevators, and ductwork. We also obviously get dust inside dust collectors and bag houses. We also get dust that accumulates in electrical panels that are in dusty environments. Basically, in the corners and recesses and anywhere that routine housekeeping misses. So in that photo there on the top, we can see there's a photo from a facility that makes wood products, wood furniture, and there is some dust that has settled there, and I don't think it has been inspected or cleaned since that facility opened. So it's just slowly accumulating fine dry powder in the elevated locations. So what are the primary hazards? We touched on them a little bit earlier in the presentation. So layer fire is one of the primary hazards. So that's basically when the dust on the surface itself catches fire. Then there's deflagration or flash fire. So when the dust becomes airborne, we get a dust cloud, and when that cloud ignites, then we get a poof or a large or a flash fire. And then if we have that deflagration, if we contain it somehow, whether it's in a building or inside some piece of equipment like an enclosed dust collector, then we can have an explosion. So deflagrations tend to be subsonic as the pressure wave goes out, and explosions tend to be supersonics or faster than the speed of sound. So we have already seen this before. This is the fire triangle. So these are the components that will go into a layer fire. So we have some kind of oxidant, like the air, a fuel source, which would be the dust, and then we have an ignition source, which could be a spark or electrical arc or cigarette or something. And we need those three components to start a layer fire. Once we get into a deflagration, the fire triangle turns into a square, and we basically just add one more component, and that's the dispersion characteristic. So if we can disperse the dust, then we can get a deflagration or flash fire. And this is what a deflagration looks like. I'll see if I can play this. And this is some firefighters that are responding to a furniture manufacturing facility in Abbotsford. This is a clip that was taken from the news. And there was a fire somehow in their dust collector. And so as the firefighters are fighting the fire, the dust starts raining out of the bottom. And so what we get is basically the air and dust start mixing together, and we get the conditions for a deflagration. So you'll see what a deflagration can do here. Okay, so that was an example of a deflagration, not an explosion, but people still can get severely hurt through burns or even knocked back and hit with the pressure wave. So deflagrations can still cause significant injury and damage. And then if we somehow confine that deflagration, so we saw how much energy was released there. If it has nowhere to go, so say if that happened inside the dust collector itself, that metal container that we saw, then we could have an explosion. So the pressure could build up to the point where that container fails, and then we have an explosion. And that's what we saw with the picture from the mill, Lakeland Mills. The building itself exploded due to the dust. And here's a picture of that. So again, the secondary explosions caused the majority of the damage in this facility. And that's when the dust became dislodged from the rafters and then ignited. And then it set off chain reactions throughout the facility. So when we're looking at combustible dust, we want to be aware of ignition sources. So not just the dust itself, but we want to also look at potential things that can cause the dust to ignite. And so here's a list of things that are common ignition sources in facilities. So static electricity is one of them. And the 30 millijoules I'll come back to in a second. Hot surfaces, heaters, open flame or smoldering material. Friction, so you can have machinery that's rubbing against each other, or a bearing that gets seized, or a motor and causes friction and causes heat. Foreign material that enters the process somehow, it gets into the process, hits some kind of blade or some kind of paddle and generates sparks. Electrical faults, lightning or wildfire around the facility, hot work that's happening inside the facility. So it might be some maintenance that's happening, throwing sparks onto some dust, sparking tools. And something that often gets overlooked is the vacuum cleaners. So some facilities might move away from cleaning with compressed air and they use vacuum to clean up their dust. But those vacuums can build up static, especially if they're not bonded or they're not rated they're not explosion rated, and those can cause problems as well. So non-static proof vacuums and their hoses can be an ignition source. Smoking can be an ignition source. And static electricity, that's an important one because on average, when you have workers or anyone walking around, when you get that static spark that we've all felt, that's about 30 millijoules of energy that gets released each time there's a static spark. So some dusts are very sensitive to being combustible, and their minimum ignition energy might be less than 30 millijoules. So that might be something you want to look at in the future when you're going down this path. Is my dust, what's the minimum ignition energy for the dust? Is it a static shock just from someone walking around and building up static on their body? Is that enough to set off the dust? That's something to be aware of. Okay, so we covered a bunch of the details about combustible dust. We haven't gone into too much depth about anything like sampling, but the first step really everything starts with this self-assessment. This is what WorkSafe is looking for. So looking at your facility, taking ownership and saying, is there a reasonably foreseeable risk present at my facility related to combustible dust? And these 4 questions can be quite helpful when looking or doing the first step at your facility. So these questions include, does our process generate dust that could become airborne? Can dust build up on surfaces or inside equipment? Are there ignition sources where dust is present or could become airborne? And if ignited, can someone become injured? So this would be the first practical step on assessing the combustible dust hazard in your facility. And again, if all these answers are no, then you could be exempt from the regulation. So it's worthwhile going through these questions. So diving a little bit deeper, question 1, do our processes generate dust that could become airborne? So some drilling down to the deeper questions, we can ask ourselves, do we grind, mill, blend, pulverize, cut, or chip any dry materials? Do we transfer dry bulk materials between containers or hoppers or equipment? Do we dry or spray dry or air convey any materials? Is there any visible dust during any normal production or maintenance activity? Even processes with low visible dust can generate fine combustible particulate over many years. So if there was a yes answer to any one of these, this would be your first flag that gets raised for question 1. The next question, drilling down, can dust build up on surfaces or inside equipment? So we can ask ourselves, is there visible dust deposits on surfaces above eye level? So we want to make sure that we're getting up high and we're looking at the rafters, we're looking at elevated surfaces at the top of machinery that we wouldn't normally look at. Is there dust accumulation inside conveyors, ductwork, or hoppers, or dust collectors? Does dust settle on the equipment exteriors, motors, cabinets, structural steel? And when are the elevated surfaces last inspected or cleaned? So these are all questions to ask yourself. So that picture on the right is a picture of a structural member in a wood facility. It's steel and it's painted green, but it doesn't look like it from the photo. So if you can't tell what color an underlying structure is due to dust buildup, then that's an indication that you might have too much dust buildup. Same with this photo on the left. If you can write in the dust and you can see that the difference there is the underlying color was supposed to be black. If you can't make that out with the dust lying on top, then we've likely got too much dust buildup. Are there ignition sources present where dust is present or could become airborne? So we want to ask ourselves, Do we do hot work near dust or where it can become airborne, even occasional maintenance? Is there electrical equipment in these zones? Can there be friction from rotating or moving equipment? Are there hot surfaces or static discharge? So if you answer yes to any of these, this will be your third flag. And if you have any flags from these questions, it's worth digging a little bit deeper. If ignited, could someone become injured? So are workers present during normal operations near dusty areas? Is the process enclosed or semi-enclosed near potential ignition zones? So again, if you have a yes, then you could be there could be a foreseeable risk for combustible dust at the facility. So any flag raised in these four questions could spur on further investigation. So now that we know a little bit about combustible dust and we have the four questions in our toolkit, the next step would be a self-assessment. So taking the questions, doing a walkthrough through your facility. So I'm signing you with some homework. Try using the four questions, maybe not this week, we're getting near to the end of the week, maybe next week. But do the walkthrough as soon as you can, not next quarter. It's just four questions. Bring a phone for photos, bring a clipboard for notes. It might be best to bring a maintenance lead or someone who knows where the dust is or a safety coordinator and document the locations that you see the dust, the estimated accumulation, any ignition sources that you observe. And if you answered yes to any of those questions that we talked about, then it's time to engage a qualified person for a more deeper dive or a hazard assessment. So what's expected now and what comes next? So expected now, before January 2027, screen your facility. So you can use those four questions as a screening step. Document your findings with notes and photos so you have something on file. And if you need to, engage a qualified person if you're unsure or if you've confirmed that the hazards are present. And then if you might need to start commissioning or getting the ball rolling on a formal combustible dust assessment for your facility if it's required based on your initial findings. Again, your facility may be exempt if you answered no to all those questions. What's not expected now is a fully completed combustible dust management program. If you have one, great. But if not, you just expect it to start the ball rolling on the initial assessment, and then the final dust management program will come out of that. Full worker training or program implementation at this point, not expected. Any capital investment or engineering controls or an NFPA level of full combustible dust hazard analysis, unless the initial walkthrough reveals a high risk and you need one right away. So just circling back to the regulation in plain language. So Works APC is amending Part 6, effective January 2027. The new sections are 6.13 to 6.137. It applies when combustible dust poses a reasonably foreseeable risk. We touched on four questions that you can use to help determine that. And it's really designed for facilities to be able to do that on their own without the need for a qualified person. And then when there is a reasonably foreseeable risk, that's when you would bring in a qualified person or qualified persons like a team that can help with that. These regulations are aligned with national and international best practices. So they borrowed a lot from NFPA, the NFPA framework. And they're also designed to be scalable. So the requirements are proportionate to the level of risk present. And so how can MSABC assist? We can help validate your initial screening, the four questions, or if you have any questions on that, we can help you with that. We can conduct a formal combustion risk assessment or DHA if needed. And we also are providing more information with parts 2 and parts 3 of this webinar series. So this first one was just an introductory webinar session, so we can kind of wrap our head around the next steps. And we can also help with the assessment program and development of any kind of dust management program. We're also available to do a walkthrough of your facility if you're still not sure and provide you feedback with the four questions or guidance, or we're available at any time. Just reach out to us. We can answer questions. So what did we cover in this first webinar? So we covered what a combustible dust is, what is a dust fire or layer fire, what is a flash fire, deflagration, and how do explosions occur. We talked about where dust typically comes from and where it builds up. We reviewed 4 questions that can help you determine risk at your facility. And we discussed what regulators are expecting at this stage and what they're not expecting. So your walkway action, do a facility walkthrough this week or next week and document your findings. So that's step 1. So we're quite a bit ahead of time here. So we have some time for questions and we'll open it up to the floor.
Just making sure. Okay, great. Thanks, Martin, for walking us through this. And again, I think it's important to know that in a lot of cases, this is a beginning step. The regulations are coming out, and so we want to get in front of this to not show any panic for members or industry, but really just to create awareness. If you didn't know, but in a lot of cases, and Martin, you may want to elaborate more on this, but in a lot of cases, having a good housekeeping program is really essential, especially if you know that you've got different types of dust that form throughout your facility, and having a good plan on how to remove that dust safely, because in some cases, you know, the, the method in which we use may actually create more risk for us in removing obviously dust on cable trays or ducting high above us. There's sometimes a desire to just simply, wipe it off with a broom or some other mechanism. But now we're actually putting all that dust, right in that fuel right into the atmosphere of the building. Oxygen, static electric spark. We've got the recipe for a potential explosion. So, having good guidelines on housekeeping. 5S, again, I go back to all manufacturers. This is a program that we support here and do provide. And again, going back to simply that concept of sorting, shine, sustainability, and onwards. This can lead to just having really good, strong housekeeping practices, mitigating your risk, but ultimately, if your business or your work environment changes, maybe you're changing your process, different machine, you've changed the ducting, these types of things all should be reviewed annually or as needed in your risk assessments and determine what steps you need to take forward. Any other thoughts on that, Martin? Let's wait for some questions to come through.
Yeah, that's a great point. So a couple of points that you mentioned. So we touched on the criteria for combustible dust. So NFPA puts out the criteria for different industries that are thresholds that are considered potentially elevated risk for combustible dust incidents above or below.
Yeah.
And so in most cases, a structured housekeeping program can keep you under that threshold. It's really when the housekeeping isn't quite cutting it, and you got to operate above that threshold. That's when you would consider controls. But in most cases, combustible dust can be addressed with housekeeping. And as you mentioned, with the cleaning of combustible dust, the instinct is to take a pressure hose or a compressed air and start blowing it off the rafters. That's probably one of the worst things you could do, because then we're actually creating a waterfall or creating a dust cloud and actually creating the conditions for combustible dust. So you really want to be careful when you're doing any kind of housekeeping, or if you haven't addressed combustible dust in years, your first instinct to go up there and knock it all down, probably not the best one. So just take care with that.
Yeah, and I think that there's an underestimation of how easy it is to have a static electric spark, which is your ignition source. And with that fuel and oxygen, it doesn't take a whole lot. And I've talked about how we had a dust hazard specialist in our training, and we provided a simple thing, an inert compound like Cremo. Taking Cremo, put it on a desk. You light it. Yeah, it's got some oil content in there. It's gonna create a small flame, but really doesn't do a whole lot. But take Cremo with air, oxygen, and add a spark to it. and it explodes. You look at the sugar, and nobody thinks that sugar is going to explode. I think we got a question coming in around, or an acknowledgement. It was a great presentation. Wasn't aware that dust generated within the nutraceutical industries was a hazard for fires and explosions. In fact, some of those chemicals are highly volatile. Some of those compounds are highly volatile and can be a perfect space for potential risk around combustible dust. Any thoughts on the nutraceutical side, Martin, from your background?
Yeah, so with nutraceuticals, you're working with many different compounds. So as Wayne mentioned, there could be, organics that are there, but there could be proteins, it could be metals. So metals are their own category when it comes to combustible dust. Metal powders, they can be quite reactive.
Yeah,
So just something to be aware of that it's not just wood.
right.
It's many different industries. Yeah.
Yeah, one of the things I'll mention is I'm seeing some questions come in now is really around, good documentation. One of the things I can really, if you know that you've got dust, so you've got good ducting, you've got a bag house, you have a cyclone, you have, different dust collection systems. One of the important things here is really having that your original engineer drawings are available for review should you ever need to. The other part is if your maintenance ever makes changes, that those changes are clearly identified and also documented because should you remove a drop, add a drop when it comes to aspiration, your CFM, your overall ability to remove the dust can be significantly impacted. You think that you've got the protection there to remove dust at source, but in fact, you might have hampered that. And so it's really important that, at the right time in those specific instances, you reach out to the professionals that specialize in ducting, in the right size motors, the right dust collection systems, the explosion, gates, and all these other things that you need. There are lots of great experts out there, and we have some partners like AirPlus Systems and others that really they're the experts, right? Reach out when you need them. There are engineers that do take care of those more complicated situations, do the right calculations, ensure you got documentation, and ultimately a PN sign off on it. So, which is critical for making sure that you're compliant to regulations. Any other thoughts on that before I move to some questions, Martin?
I think we're good to look at some questions. Thanks, Wayne.
Okay, great. One of the questions coming in, would you consider a plastic injection molding process within a machine a dust creator? These parts are not shaven down, but pieces are sometimes cut off the parts. So thoughts on that?
It's a good question. It could be. It all depends on the situation. So I hate that answer. It all depends. But for example, I took a look at a dairy facility, and they are using resin for injection molding of bottles. And
Yeah,
that process was creating a lot of dust. They weren't cutting it, they weren't grinding it or anything, but there was plastic pellets. Also, maybe the plastic pellets that the plastic comes in that can generate dust.
yeah,
The thing when it comes to plastic pellets, they can also build up electric charge.
yeah,
So how they're being stored, if they're being stored in a silo, and also there's studies on this. If you have, how is it being stored in a silo or a hopper? If there's a cone, one particle that's just rolling from the top of the cone down to the bottom can pick up a charge and then let off a static spark when it hits the bottom. So these are all storage requirements just for the pellets when we're not talking about the product that's being made, but just storage. These are all things to think about when it comes to dust. So kind of
yeah.
want to look at the overall picture. I can't give you a blanket yes or no, but it'd be good, to look at the different aspects of the process.
Yeah, yeah, no, I totally agree with that. Got another question coming in is this one is a good one. Is aluminum dust combustible? It's a bit of a loaded question, isn't it?
It is. It's an explosive question. Yeah, it's yes, yes. So aluminum is one of the more reactive powders when it comes to explosions. So
Yeah.
it especially the finer it is, the more powder form it is, the more reactive it can get. Good question.
Yeah, yeah, exactly. And we see that a lot of people think that metal dust is not because it's metal. They're thinking, well, maybe it won't explode. But in fact, in some cases, right, certain metal dust coming in contact with water can become very reactive, not just with oxygen and a spark, right? So again, reach out to us. We've got folks that can answer those questions for you and provide you with the support.
Yeah, and
Another
that
question
reminds me
here.
actually
Yeah, sorry,
before,
go ahead.
yeah, that reminds me, I did a recent combustible dust assessment, and the question, when we do the assessment, the question is always, have you had any incidents? Because that helps us with information. Have you had any fires, any incidents? And the facility deals with metal powder, and when there's waste from a cutting laser, it gets sucked up into the dust collector, and then it goes into a bin, and then it gets wheeled outside for disposal. And sometimes the bin gets left open. And so we were asking, was there any incidents? No, no, no. And then, oh, wait a second. Yeah. One
Yeah,
day we wheeled out the cart and it rained onto the metal powder and the metal powder caught fire.
yeah, exactly.
And that's waste powder. So stuff that you might not think about. And also, that's why we want to kind of dig with these questions during a DHA. You always kind of want to dig down and drill a little bit deeper because there's things that you might not think about.
Yeah, absolutely. Yeah, good point. Um, Question here around qualified people. Who is WorkSafe defining as a qualified person? As I don't believe that there are any officially recognized certification for combustible dust hazard management. And I would say that, even for us, we've invested heavily in our hygienists and a few other specialists within our organization to take on and do some specific training with regards to DHA, and also some opportunity for mentorship with dust hazard specialists. But to your point, from a qualified perspective, there's no guidelines that we've been provided at this point, and we are waiting as WorkSafe does provide some guidance on one, the rollout of these regs, how they will enforce them, and what things we should be concerned in supporting members on. So you're correct in that there's not an official recognized certification. There are some trainings that are out there. They're very expensive, and they're not easily found. But yeah, we're not aware of any designation of expert per se, but we do have people with good experience and good knowledge through some training. And we continually reach out to industry to ensure that our team is as best prepared to handle the DHA side of things for our industry. And Martin, anything to add to that from your perspective?
Yeah, that's a great point, and I know that WorkSafe is working on guidelines that'll be accompany the regulation, and hopefully that definition gets a bit fleshed out a bit more.
Yeah. Engineer controls regulatory expectation. Could we comment on what WorkSafe's timeline expectations are for completion of capital investment in engineering controls? I do not have an answer for you on that. I know that they have a task force that they've put together, a group that's meeting, and they will be discussing and providing some guidance on that here over the next few months. And I think by the fall, we'll be in a good position to be able to answer that question. So do tune back for the other sessions because as we get more information from WorkSafe on their guidance, we'll be bringing that in these additional sessions. Another question here, Martin. We've got for context, who decides if a full NFPA level audit is required before January 2027? Is this up to WorkSafe? Um, so guidance on that from your perspective, Martin?
That's a good question. So our process here at MSABC, we have a screening step. So in addition to your self check, which is what WorkSafe is expecting, kind of a walk through your facility, we also do a walkthrough as well to verify that check. And if there's a foreseeable risk, then we'll put a recommendation for further DHA. And in some cases, we'll say that there's nothing, no further, well, no further investigation is recommended. So I'll give an example. There was a facility that was using flour to, I think it was 2 days a week. They were making up some kind of flour paste, and then they would use the paste, which it doesn't at that point doesn't make dust, but when they're making the paste, they would make it twice a week for about 2 hours on a shift, and they would clean up right after. So there wasn't, and I took a look at the facility, ran my finger around. It was confined to a small area, and there wasn't any foreseeable risk here. So that's also what WorkSafe wants to um, um, try to avoid is, let's say a restaurant where they use a cup of flour to thicken up a gravy. That's a lot different than, a full scale operation where there's dust. So, that's where that kind of judgment comes in, where a qualified person can take a look at it and recommend further analysis or not.
Yeah, yeah, I would agree. A little bit of common sense here, right?
Yeah.
I think it has to be applied. Does WorkSafe plan to cite NFPA in their combustible dust guidelines as either best practice or implementation requirements?
That's a good question. I know that a lot of the just from background discussions, I know that a lot was pulled from NFPA. Whether they will
Yeah,
explicitly list it, we're still waiting to see the guidelines be drafted. But there's other standards out there. There's ISO. There's other things that can be, and they're pretty much the same.
yeah,
Uh,
they do
so
stack up the
yeah,
same. Yeah.
yeah,
I would say the guidance that I would give to anyone is tune back, but most likely it will be cited and it will be a framework. It is the probably the more cited framework when it comes to DHA. So I would expect that it'll be around or including some of it. Yeah. Ignition sources and controls. In a wood dust environment, is a certified explosion-proof vacuum a requirement, or would a non-static pneumatic vacuum meet requirements? Well, that depends. Martin, I'll pass that one to you.
that's a good question. I
Yeah.
would err on the side of caution for now and say most likely it is, yes. But I would have to refer back to NFPA. I don't have that answer off the top of my head, but there is a section there in NFPA that'll talk about vacuums.
Yeah, and I think even as technical safety, if you look at them and their environments, they're citing NFPA standards as well. It is the higher, I guess it's the higher standard, so to speak. And I would just say that in any wood dust environment, a non-static explosion, kind of, a non-static version is probably, your best bet regardless. I mean, you want to make sure everything's grounded. That is your
Yeah,
that is your risk mitigator for potential spark and an unknown spark because it can happen at any point. Because as you said, that static charge can build up in different environments, right? If you've got certain materials around dust sliding across nylon, easy to see how that will create yeah, potential for buildup of spark, and there's many more. So again, erring on the side of caution, I think, is really key here.
yeah.
Yeah. From an assessment side of things, what would be the best approach to evaluate steel grinding dust? Again, I think, just having a look, giving a bit more background on this, grain size, energy required for ignition energy, are these key factors? Martin, your thoughts on that?
Yeah, and it just reminded me to that previous question, what would be the trigger for a DHA, a more further investigation? And there's a test, it's called a go, no-go test. So if you're unsure about the dust, whether it's combustible or not, there's a pre kind of screening test where you can send a portion off to the lab, and if they run standardized tests on it, and if it combusts or deflagrates, they'll tell you whether it's ignitable, or they'll give you the go no go to proceed further. So that's why it's called go no go. Do I go with the DHA or do I not go with the DHA? So that screening test can help answer that. When it comes to steel, grinding steel, um, again, metal dusts are their own category in NFPA, and they're treated with caution because they can be quite combustible, quite reactive. If you think of steel wool, if you can light that on fire, then steel grindings would kind of be in the same category because you get a mixture of fines and powders. So I would say that it could most likely be, but if you really want to be sure, then you can get your dust tested. There's also a database that'll tell you. It's called uh, Justice. It's a German database, and it won't. You can't exclude your dust because it doesn't have every kind of type of dust there, but it can tell you whether you likely have a combustible dust or not. And steel grindings will likely be there. Should be noted that a maintenance shop, like where you're just kind of welding you have your tools there and whatever, is not the same as a full production facility where there could be metal dust in significant quantities. So they're treated a bit differently. So if you have like a maintenance shop where they do a little bit of welding, a little bit of grinding once in a while, that's treated a lot differently than an actual facility where there's processed dust that are metals or fine dust that's coming off and building up in large quantities.
Yeah. Further to that, Martin, I mean, size, does it matter?
Definitely. So the finer the powder, the more surface area the particles have, and the more reactive they are. Yeah. So size does matter.
Yeah, so I think again, just again, looking at this from a common sense, there are known, and we can provide a list, known combustible dusts, and that's the known. It's when you've got unique circumstances within
Mhm.
your facility, you're using maybe some different types of compounds, you're unsure, then reach out. But a lot of this stuff can be easily
Yeah.
determined for you. It's when we get into specialized compounds and special manufacturing settings where maybe you're using something that has not been listed, but maybe you need to have it looked at or tested. But again, I
And a
wouldn't run
good,
out to get test everything.
yes, exactly. A good place to start would be the STS. The
Yeah,
STS might have already got that info for you, and that's a good place to look at whether it's flammable or combustible. So you don't want to
perfect.
reinvent the wheel. It might have already been tested.
Yeah, I agree. One last quick question just before we get close to the top of the hour here. One business had their dust te tested 6 years ago and had to send it to a US testing facility. Are there any testing facilities in BC or Canada? And of course, we're concerned about this too. Your response, Martin?
There is one, last time I checked, there is one in Canada. It's on the East Coast.
Yes.
And there's two other facilities that we're aware of in the US that are reasonable. But I'd imagine that number might be growing, but right now that's all we're plugged into.
Yeah, and I think it's important just as we come to wrap up here that this is unique. I mean, WorkSafe is leading around the changes to the regulatory requirements around combustible dust. If we look at other regulators across Canada, I think this is unique. It will be, I think, a standard worth understanding better. But I think the big thing from us, from the manufacturing safety lines, is don't panic, right? Again, if you are unsure, reach out and we can provide some guidance. But in a lot of cases, we can give you a good, solid risk assessment of a framework to assess your risk when it comes to dust and putting in some mitigation controls like housekeeping. Again, I think you should adopt 5S because that really, that stems to everything, slip, strips, falls, dust challenges, you name it. But again, ensuring that you don't panic. Like this is not a panic. This is a change in the regs. We want to get in front of it. But for those organizations that may be concerned because they do emit a lot of dust, these will be a more prescriptive regulatory change that you would need to adhere to. And so we're here to support. But again, Martin, I want to thank you for being part of the initial rollout of this series. I think you've got a lot of great stuff in your slides. If anyone wants to reach out, Martin is one of our hygienists, and he'd be happy to answer any of your questions. If you want to get a copy of the slides, certainly we can make that available to you. If we couldn't get to all the questions, we will try to answer them and get those back to you. We also will have a copy of the recording available. Again, check us back again as we bring the next series later I think we're looking at July, August, and then into the fall. So thank you for joining us. A few closing comments before we wrap up today. Join us next Thursday for a new webinar on building resilience through uncertainty. We, of course, know the world is a little uncertain, lots of things that certainly I think our employees are all facing in the backs of their minds. So please join us with Dr. Steve Conway next week. and will teach us about some practical tools to help your team stay focused, stay responsive, and ready to perform during those times of uncertainty. I think there's going to be a lot of new takeaways and strategies to manage stress and anxiety and turn insights into daily leadership habits. So please register through the link in the chat if you can, and we look forward to seeing you there. I want to make mention we are selling tickets fast for our 2026 Safety Pinnacle Awards, and we're excited. We've got a bit of a new format, and it's going to be also given we support the food and beverage industry. It's going to be a bit of a foodie event, so join us for some fun and inspiring evening at the Sky Hangar on June 18th to celebrate your team's achievement in occupational health and safety and well-being with other BC leaders and companies that are making a difference. Additionally, watch for our email with a link to the recording for this webinar, and please share your feedback. We need that. We'd like to know of other topics that you would need or find of interest so that we can present those for you at a future date. So as we bring this webinar to a close, thank you again for your support and for reaching out to the Alliance. And again, if you need anything from us, you know where to find us at Manufacturing Safety Alliance bc.ca. And we look forward to seeing you at our next webinar next week. Thanks, everyone.